Hello. Now we're going to be talking about how to graph rational functions. Here we have the rational function f of x is equal to 5x minus 1 divided by 2x plus 3. First, we will be able to find what the graph is if we are able to find, let's say, the vertical asymptote first. To find the vertical asymptote, denoted by VA, we set the denominator equal to 0 and solve for the corresponding x. What you get is negative 3/2. So that's when we're dividing by 0, and so the graph should not allow that to occur. So that's when we'll get our vertical asymptote. Our horizontal asymptote, as we've talked about in the other video, is when we take the limit as x approaches infinite values of 5x minus 1 divided by 2x plus 3. Here, since it's the first case where the degree of the numerator and the degree of the denominator are equivalent, this becomes just a ratio of the leading coefficients, 5/2. Okay, so that's our horizontal asymptote. Now, don't forget that we can also take the limit as x approaches negative infinity. And actually, in this case, we get 5/2 again, because although they're negative values, the negative values will cancel. Okay? Now that we've discussed what the vertical asymptote, what the horizontal asymptotes are, we can find, let's say, the x-intercept, the y-intercept. Right now, this is equal to a y. The x-intercept is whenever y is equal to 0, okay? So the x-intercept is when y is equal to 0, and we solve for x, the location of that. So that's 5x minus 1 divided by 2x plus 3. I multiply both sides by 2x plus 3, and I get 5x minus 1 is equal to 0. Then I solve for x, so I get 5x is equal to 1 divided by that x is equal to 1/5. This is the x-intercept. What is the y-intercept? Well, that's precisely when x is equal to 0. So here, whenever x is equal to 0, in this function, we're going to have 5 times 0 divided by 1 divided by 2 times 0 plus 3. So I get negative 1/3. Here is the y-intercept. So in our graph, we know the function has a vertical asymptote and negative 3/2. So here's negative 1, here's negative 2, negative 3/2 will be right here. There's our vertical asymptote, and then our horizontal asymptote is going to occur at 5/2. So here's 1, here's 2, here's 3. 5/2 is somewhere halfway in between 2 and 3, because 2 goes into 5, 2, 4, 2 in the little bit. So the horizontal asymptote will go through here, as we can see here. Then the rest is to find the y-intercept. So the y-intercept was at negative 1/3. That means it goes through the y at negative 1/3, and so that's where it would be right there. And then the x-intercept, we found that it's at 1/5. So if this is 1, then 1/5 is right here. That's the x-intercept, and I claim the function, the rest of it will have to adhere to all of this information. Okay? So, what does the rest of the graph look like once we've drawn that? What does the rest of the graph look like? That is what we will be able to determine using an f of x table. Okay? So our f of x table, let's pick some values about the origin, negative 2, negative 1, 0, 1, 2. And let's find f of negative 2. F of negative 2 is equal to 5 times negative 2 minus 1 divided by 2 times negative 2 plus a 3. This is equivalent to negative 10 minus 1 divided by negative 4 plus 3. This is negative 11 all over negative 1, which cancels out to be positive 11. What is the function at negative 1, well, that's f of negative 1. This is equal to 5 times negative 1 minus 1 divided by 2 times negative 1 plus 3. This is equal to negative 5 minus 1 divided by negative 2 plus 3. This is negative 6 divided by 1, which ends up becoming just negative 6. What is the function f of 0? Well, that's just negative 1 divided by 3. What is the function at 1? Well, that's just 5 minus 1 divided by 2 plus 3. So that's 4 over 5. 5 minus 1 divided by 2 over 3. Yep, that's 4 over 5. Then what is f of 2? Well, that's 5 times 2 minus 1 divided by 2 times 2 plus 3. This is equal to 10 minus 1 divided by 4 plus 3. This is equal to 9 divided by 7. Now, whenever you plot these points, you should get what your graph looks like, okay? What I'm claiming is your graph is going to look something of the form like this. And it's going to go through these 2 points. Why is it that I say that? Well, we can see numerically here that at negative 2, it's at 11. So at negative 2, we go all the way up here. We said this is at 11. I'll maybe use a different color here to make it distinct. On here, negative 2 is 11. At negative 1, it's at negative 6. At negative 1, as you can see here, it'll touch that negative 6. At 0, we know it's negative 1/3, as we've already found the y-intercept. Then we continue on to, what is it, at 1? At 1, we find it's 4/5. So as you can see here, this is approximately 4/5, almost 1, but no cigar. And moving on, let's say, where is it at 2? At 2, we've discovered that it's at 9/7. So we move over here, and this is 9/7, slightly above 1, but not exactly 2. So as you can see, your f of x table, along with knowledge of the vertical asymptote, the horizontal asymptote, the x-intercept, the y-intercept, these values will allow you to discover what the graph of a rational function looks like, and it's not so bad. Please leave me any questions or comments you have, either via email or in YouTube. See you guys later.